Here, a physics book is on a tabletop, and somebody smacks it, slides along the table, off into space. This is exactly the same situation, almost exactly the same situation as Thelma and Louise. There's a horizontal portion of motion, and then there's a vertical portion. This book comes directly horizontal off the table, so its initial velocity we could imagine right here at the edge to be directly horizontal. Now the example I'm going to use is, I'm going to have ridiculous numbers. So it says it comes off with a velocity of, say, 3 meters a second. You'll have different numbers probably. And it strikes the floor in, I'm going to say 0.6 seconds. So the table I'm talking about is probably a high shelf, and someone is really, because 3 meters a second is pretty fast, so someone is really upset and they smash the book. What's very important to recognize is that because it's coming off of a horizontal table, this velocity of 3 meters a second, this initial velocity, is purely horizontal. There's no vertical component to it whatsoever. It's not flicking the book up nor down. So it will fall in exactly the same amount of time as a book dropped from the same height table. So find the height of the tabletop above the floor. That's a time. Oh no, that's a distance, pardon me. And we can use one of these kinematic equations with acceleration in them. And because this is on Earth, there's going to be the acceleration downward due to gravity. So if I set up a little coordinate system for myself, we will consider the height. People like to consider that positive. So if I was to draw myself a coordinate system, I think I would draw it like that, with the x-axis starting right at the edge of the table and the y-axis starting at the floor. So all distances above y, above the floor, are positive, and all distances off the table are positive. So if there's my axis, I want to know the height, and I have a time, I have a initial velocity, so I don't have a final velocity, so I don't want to use this equation or this equation. So I'm going to use this one. So you can see my strategy for choosing equations is a little ad hoc. I just ask myself what I don't know. That has to be part of the equation. Then ask myself what I do know. What I don't know and want to know has to be part of the equation, but what I don't know and don't want to know shouldn't be part of the equation. For example, I don't know the final velocity, and I'm not trying to calculate it, so I avoid equations with it. Sometimes you have to calculate things you don't know to sort of corral or work your way towards ultimately what you're trying to find. So my final position, now this is my basic kinematic equation. This is on our equation sheets. I'm going to convert this into the vertical, so x's are now y's. I'm going to remind myself here, just on the side, that I'm talking about the vertical direction now. We're talking about time it takes to drop. This is motion up and down. Just remind myself that this whole thing is in terms of y. My final position is the floor, which because of my coordinate system here, I can determine that's 0. My initial position is at the top of the table. That's I'm going to put h. I'm going to call that h. So I'll label it right here. H is this. Well, it's not a distance. It's actually a position. So I'll call this h up here. My initial velocity. Now this is in the vertical direction, and here's a point at which it's easy to make a mistake. You think, yeah, this thing's going, it's moving. Of course it's going to have some effect. This is a purely horizontal velocity. The vertical velocity, the vertical component of this is 0. It's not moving at all in the vertical direction. So this delta t here doesn't matter. Acceleration is, I'll just draw it in here. It's g, I drew it there. It's g downwards, so that's negative g relative to my coordinate system. And the time is what I'm trying to calculate. Oh no, the height is what I'm capturing. I have a time, 0.6 seconds. It's going to be squared. You have one unknown. It's here. So this has there's a negative there. Just bring that over and solve for h. The lesson here is don't be confused by this initial velocity in the horizontal direction, thinking that it has any effect on how the object falls.